Hi, everybody. Welcome to the lesson this evening. We're going to be looking at trigonometry graphs. And I've got a question there for you. If you can just think about this question while we wait for others to join, that will be great. And the question is, what is the period of a sine, cos, and tan graph? And remember, the period must be in degrees. And yeah, the period, how many degrees does it take to complete a full graph? It can be sine, it can be cos, or it can be a tan graph as well. Welcome, Asamahle. Welcome, Joy. How are you doing, Reborn and Vuyo, and Solo Fellow as well? Welcome to the session. Going to give it another 2 minutes and wait for your colleagues to join, and then we can get started. Welcome, Sesetu, Sinesipo. Welcome to the session. Maybe if you can all, if you want to unmute or type in the chat, what is the period of a sine, a cos, and a tan graph? Remember, they don't need to all be the same. They are possibly different. Or maybe two of them are the same. Maybe you can tell me. Okay, let's have a look. Lisa, do you maybe have an answer for me? What are these periods in SC4? You're welcome to unmute, or you can type in the chat. Joy, Rebone. Also, maybe if you can show me a thumbs up, those of you who are also on the live stream. How many of you have done trig graphs this year already? You can just show me a thumbs up. Not many of you. So Setu, have you not done it this year? Oh, Asamatli is done. Okay. We've got, okay. Okay, some of you have done it. Okay, so what is the period of a sine, cos, and tan graph? Because you haven't given me answers right now, I'm going to actually answer this question in the lesson because I didn't receive much answers from you. So I'm not so confident. I don't want to give the answer right now because I want us to go through the work so that we can gain confidence in this section before answering that question, right? Okay, so let's look. I'm going to share a graph here. Well, not a graph, some graph paper. So we've got this here. And you can see there's different angles there. We've got 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? So yeah, I thought I'd draw the graphs free-handed with you rather than just showing you the graphs. So if you have some paper and a pen or pencil, I think it would be really nice if you can just draw this axis out. I'm going to just do this. Be focusing on this part here. And you don't need to draw too many lines, even if you just want to draw the degrees, which is 90, 180, 270, and 360. You don't need to draw everything like all the lines in between, but you can just draw, yeah, and then 1 and -1, right? Okay. You can just draw that out, and then we're going to look at some graphs. Okay. You can just show me a thumbs up. How many of you have drawn the axis out yet already? Okay, thanks, Lisa. What about the rest of you? Boitumelo, have you drawn it out yet? Thanks, Vuyo. Thank you, Sinesipo. Okay, so say to all of you, great. Asamatle, welcome. Thanks for that. Okay, so we're going to draw the first graph, the sine graph, right? So y equals sine theta. Let's write that down. Y equals sine theta. Okay. Now this graph, it has turning points at 90 degrees and 1 there, and 270 degrees and -1 here. It also has turning points on the negative side, which is -90 degrees and -2 and -1, sorry. So there. And then we've got at -270 degrees and 1. Okay. I hope that's in the right spot. I think it is, yeah. Okay. Okay, so now we're going to connect them. Okay, so let's do this. So we're going to start at 0 here, 0 and 0. Right? I think this color is a bit not very clear. Let me use a bit of a, there we go. Let's use this color. Let's use the purple. So we start here, and then we go up here, and then we come down and we go through 180 degrees. right? We're going to go through 180 degrees. Sure. Okay. I think that's relatively decent. I always get a bit stressed when I draw them free-handed using the stylus, but I think that's okay. Let's now go down, draw here. And then it goes through minus 180. Okay. I don't really like how it turns here. It should actually turn nicely, right? Let's try and do that differently. Like that. And then it turns here. And it goes through to 360 degrees. And this is y equals to sine theta. Okay, so once you've drawn it, let me know. This is y equals to sine theta. Okay, great. A lot of you have it down. That's perfect. Excellent. Those that have your calculator with you, I want you to plug in your calculator sine 90. Just plug it in and let me know in the chat or unmute. Let me know. What does it tell you when you press sine 90? What does it say? 1. Yes, thank you, Sipo. Thank you, Lisa. So that's why we have this point here, 90 degrees, which is x, and the y is 1. I want you to press for me sine 180. What does it give you? Sine 180, what does it give you? Thanks, Oratilwe. Thanks, Rebone. It gives you 0. I want you to press sine 270. What does it give you? Yes, thank you all. Minus 1. And 360 will give you 0 as well, right? So can you see how we get this graph, right? And if you press sine 0, obviously you get 0. And the same will work with the negative side, right? Okay. So how many degrees do you think it takes to complete to complete one full graph? How many degrees does it take to complete one full graph? Yes, that's right. So from here to here would be one full graph. It's 360 degrees, right? So the period of this graph is 360 degrees. Okay, period of the graph. (360 degrees). And what is the height of this graph? What is its amplitude? What is the height of this graph? How tall is it? 1. Yes, this is the height here. Thanks for that. So the amplitude of this graph is 1. So the period is the degrees to complete one full graph. and the amplitude of this graph is 1. Excellent. Thank you so much, everybody. Focusing only on the one that I've drawn here. What is the range of the graph? What is the range of the graph? Focusing only on this one that you see on the screen. There can be many other sine graphs and things, but this one that I've got, y equals sine theta. What is the range of this graph? What is the range? Range would be the y values. What is the y values between Valerie, Vuyo, Trish? What is the range of this graph? What are the y values between? Okay, yes, thank you for those answers. So it is between -1 and 1. So the range is -1, y, and 1. So it is between -1 and 1. Okay. And this particular sine graph that I've drawn here, what is the domain of this one that you see here, the one that I've drawn? What is the domain here? This particular one, the domain is the x values, is between 360, -360 and 360. But had I taken this graph and made it a bigger graph, it could have been larger values, right? So here it is between, the x is in this graph, not all sine graphs, because some sine graphs can be bigger. You can draw them with a much broader domain, but this particular one is between -360 and 360, right? Okay. So this is your sine graph, and we've got period and we've got amplitude, right? Okay. Any questions regarding sine graph? No? Okay. We're now going to go to cos graph. I need to open that graph up again. Where is it? Whoops. Let's find it again. Here it is. Okay, let's put it here. Okay, now we're going to go to y equals to cos theta, right? Let's do this. And we write it down. So this is the next one, cos. So we're going to say here y equals to cos theta. Okay. Okay, thank you. So the cos graph, y equals to cos theta, and we need to know how to draw this graph, right? Okay, so this graph is a bit different to the sine graph. The shape similar, but the points are going to be different. So this one starts at 1 here, and then it turns, it touches or intersects the axis here at 90, and then here at 180 degrees it turns, and then 270 degrees it touches again, and then it stops here at 360 degrees. Again here, -90, and then 180 here, 270, and then here 360. Okay, and then we're going to be connecting these points. Right, let's connect the points and you can draw it with me. Not so bad, and don't feel scared to draw it because you've got your pencil. You can draw it with a pencil and an eraser. As you can see, my graph is not perfect, but you can try your best to make it as decent as possible, right? Going through all the points, all right? Yeah, so it starts at 1 and then it goes through this point. Let's check it, right? Plug into your calculator cos 90. What does that tell you? Trish, you've got your hand raised. Do you have a question? Trish? You're welcome to unmute or type in the chat. Oh, it's okay. Okay, plug in your calculator cos 90. What does that tell you? When you press cos 90, what does it say? Zero. Okay, so this is 90 and 0. What about cos 180? What does that tell you? Can you see? We can check our graph like this, right? So this is your cost graph. Let's write some information regarding this cost graph here. What is the period of a cost graph, everybody? How many degrees does it take to complete a full cost graph? Okay. At 360 degrees. That is indeed correct. So it's 360 degrees to complete a full cost graph, right? What about the amplitude? How tall is this graph? How tall is this graph? It is? Yes. You can take a try and look at the graph. How tall is it here? How tall is it here? See? The distance from the maximum point or the minimum point to the x-axis, right? So it's going to be 1. So the amplitude is 1. And the range is between -1 and 1. There we go. Okay, so this is your cost graph. Okay, so y equals cos theta. You can just show me a thumbs up, those of you on the live stream, as well as those of you in the lesson. Show me a thumbs up that you've drawn it, and please, you're welcome to ask any questions if you have any regarding this particular graph.
Hi, sir.
Yes, Sunita.
I'm meaning to ask you, the cos graph and the sine graph are the same, right?
They look different, Sinesipo.
But the period, the amplifier, and the range are the same, like.
Yes, yeah, the period, the amplitude, and the range is the same, but the intercepts, where it cuts the x-intercept and the y is different. Yes, Sinesipo?
Okay, I hear you.
Yeah.
Thanks.
Okay. Okay, any questions? Nope, okay. So then we move on to the next one, which is the cost graph. Let's put this back in here. Okay, so this is the cost graph. Right, so this graph, I would like you to take your calculators and say, did I say cost? I'm supposed to say 10. We're doing the 10 graph. Eh? Yeah, I'm sorry. Thanks, Lisa. I said, I don't know why I said cost. It's supposed to be the 10 graph. Yes, we're doing the 10 graph. I want you to take your calculator and plug in there 1090. 1090. What does it tell you? Error. Okay. 10 to 70. What does it tell you? Ten minus 90. What does that give you? Error as well. Yes. So they are all errors, right? And why is that? That is because 90 degrees, 270 minus 90 and minus 270. Does anybody know what we call those in the 10 graph? What do we call those points on the 10 graph? Those of you who have done the 10 graph, what do we call those points? What do we call those? Anybody want to take a try? The asymptote. Oh, let me see. Somebody writing something. Yes, thanks to Melo. Thanks, Oratilwe. The asymptote. So these are the points that the 10 graph does not go through, cannot go through. It gets stuck there because it's error, right? So those are the X points that it cannot go through, right? So we put dashed lines here like that, see? Okay, so that's 90 and 270. Okay, so that's your asymptotes, right? Okay, so we're going to draw a 10 graph now, taking into consideration the asymptotes, and this is how the graph looks. I just want you to, okay, let's just draw it, right? So we've got here. Here we go. Then here. Can't touch those points. And then here, like that. Yeah. Okay, and we do the same thing on the negative side. So it goes here. Like this, right? The graph doesn't touch any of those dashed lines, right? And this is your tan graph. Now, I've shown you specifically two interesting points. I want you in your calculator to place tan 45 degrees. What does it tell you? Right, so it's nice to show one point at least on your tan graph, and I've got this point here, the 45 degrees and the 1, right? So this is our tan graph. What is the period of this tan graph? How many degrees does it take to complete an entire graph for tan? Yes, it is 180 degrees. Okay. And this graph, it goes indefinitely towards the positive y and the negative y. So we cannot say that it's restrained by any of the amplitude. We've got the range, which is negative infinity to positive infinity. Okay, my infinity sign is a bit strange. Let's do that. And there we go. And this is your tan graph. Maybe if you can just type a message in the chat, just let me know how are you feeling about your three graphs, sine, cos, and tan. Lisa? No? Okay. Anybody else? You're welcome to also send a thumbs up if it's going okay. Okay, thank you, thank you. Thanks, Lisa. Thanks, Tumela. Thanks, Joy. Lisa, you are unmuted at the moment. So you're welcome to share anything you're wanting. Uyo, it is 180 degrees because this is the full graph, see? Sorry, Lisa? Sorry?
I'm saying I didn't realize I was unmuted.
Okay, no, it's not a problem. Do you have any questions? Okay, great. Okay. So yeah, it's between, say the period of this is 180 degrees because it's between 90 and 270 or minus 90 and 90. Does that make sense for you? Okay. So we're going to look now at some changes in these graphs. What happens when we get changes, right? So I'm going to look at the first one, which is the changes in the amplitude, right? Change in the amplitude. Okay, so this is the first change, right? The change in the amplitude, right? So our original graph would be y equals sine theta, right? Like the one that we drew earlier. I'm going to draw a very rough sketch of this one. Like that. Remember, what was the highest and lowest point here? Well, the y values, what was it? 1, 2, 3, what was it? Yes, it was 1, right? So that's the original. This is y equals sine theta. The change in amplitude is documented by what is in front of the sign here. And in this case, we have 1. That's why its amplitude is 1, but we don't really show the 1, but it is, there's a 1 there, right? So we usually say the standard form of this graph is A sine theta or A cos theta or A tan theta, etc. Right? So if the amplitude changes, we can get a graph like this. Y equals 2 sine theta. What will the amplitude now be? You can type or unmute. What will the amplitude now be? It will be 2. So this one was 1 and minus 1. So the new one will be 2 and minus 2. Whoops. Like that. So that's 2 and minus 2. And that's the new amplitude. Does this make sense, everybody? Yeah? The amplitude changes. Okay, thank you, thank you. Yeah? See? New amplitude. The same can happen with the cos graph or the tan, for example, when you press tan 45, it will now tell you 2 instead of 1, right? So that's the graphs change based on the amplitude, right? Okay. Then we get changes in the period. Any questions though regarding changes in the amplitude? No? Okay. Then we get changes in the period. So remember, let's write down our equation again. It's y equals to a sine x. This is the standard, right? When we add period changes, we assume that the original would have been here, would have been 1. So it's like sine 1x, right? But we can write this as another standard form, which is a sine bx. Sometimes at your school, your teacher could actually not make it like A and B. They could add some other alphabets in there, F and G or something, something different. But we're going to use this. So this B here for us would be the change in the period. Okay, so how does it change exactly, right? Let's look. So our original graph was, I'm going to draw another rough sketch here for you. Our original graph was like this. That was 180 and that was 360. And this was a sine graph, right? Okay. So if we get something like, say, let's see, we've got, say, the graph tells us y equals to sine 2x. What this now means is instead of being able to fit only one graph into 360 degrees, we are able to fit two graphs into 360 degrees, right? So let's mention that again. So instead of fitting one graph into 360 degrees, we can fit two graphs into the 360 degrees, right? Okay, so you can write that down. So instead of being able to fit one graph into 360 degrees, we're now able to fit two graphs into 360 degrees. So the period of the graph actually changes to 180 degrees. So When you've got 1, it is 360 degrees. But if you've got 2 here, the period changes to 180 degrees. So we can fit 2 graphs in there, right? So let's draw it out. Can you see? I've got one graph here and another one here. And the period changes to 180 degrees. Here's the period here. 180 degrees, right? Okay. Any questions regarding this one? If you can just show me a thumbs up or a thumbs down about this, just to help me understand where you're at. Is this okay for you? Okay, great. Thanks, Asamate. Thanks, Joy. Thanks, Lisa. Thanks, Inesipo. Okay, that's great. Oh gosh, so many thumbs up. Okay, Tumelo, Vuyo, Trish. Great. Okay. And the last change I'm going to look at today is the shifts in the graph up and down and left and right, right? So the next one is the movement left, right, or the graph moving up or down. So remember, our graph currently is y is equal to a sine bx. That's where a is the amplitude and b is the period change, right? Left and right would be, I'm going to put this in another color. Y equals a sine bx plus or minus c degrees, and then the up or down is plus or minus d, right? So let's label this. So a was our amplitude. Change. B was our period change. C is the movement left and right. I'm just going to say a L and R. And then D is the movement up and down. Okay. Plus C is left, minus C is right. Plus D is up, and minus D is down. Okay. So if I give you a graph like this and I tell you, let's see. So if I tell you here, y equals sine x minus 20 degrees plus 2. What happened to this graph? If you can just tell me, what happened to this graph? You said minus 20 plus 2. Can you tell me, did it move up, down, left, right? What happened to it? If you can just type in the chat or unmute, let me know what happened to it. Yes, sure. That's really great. Well done, everybody. So that it moved right and it moved up, because this one says to the right, because it's minus C. And it's plus 2, so it's up. Yes, great. Thanks, Oratilwe. Yes, Inesipo, that's excellent. Lisa as well. So yeah, you're going to see in the homework, there's going to be lots of interesting exercises like this that you're going to do and you're going to look at. And in the revision lesson, we'll go through more activities related to this. So yeah, are there any questions regarding this? Nope. Okay. Thank you. Thank you. Okay. So I think that is it for me today. We are going to be doing some revision very soon, but I've given you lots of homework on this activity for you to practice more. I'm going to hand you over to Nikayla, who's going to tell you where we're at and what's for homework. Thank you so much, everybody.
Hi, everyone. It's nice to see you again. And yeah, I'm just going to go through your homework quickly. But before I do that, I also just want to say I've seen a lot of people on the live lesson as well. So yeah, just a hello to those people. And yeah, it's good to see that you guys are engaging. Okay, so just to go through the homework. Just gonna share my screen. Okay. Okay, so as you can see, we're coming to the end. Our last lesson is on the 30th, so everybody knows. And we have a leaderboard today. And we have Oratilwe at number 1 with 7 activities done. We then have Valerie and Tokozani both together at number 2 with 6. We have Tsolofelo with 4, Lumka and Joy together with 3, and Relebohile and Sabelo with 2. So well done, guys. And here's your homework. You're going to go into functions and relationships under your topics. Once you click into that, it's quite a bit of homework once again, but it's all of the activities under trigonometric functions. So I'm just going to leave all of that up for you guys. And yeah, also just the reminder to share the Zoom link to have your friends join. Okay, so I'm going to leave your homework up for you. All the best. And yeah, we have a break soon, so I hope everyone gets some rest in that break time.